Thank you for joining us today, and in this video we are going to practice on average and instantaneous rate of change. Let's jump right in. So now we have a function f of t which is equal to 1 minus 2t squared. And we want to find the average rate of change at t is equal to 1 and t is equal to 1 plus h. Right. Then since this depends on h, it will help us to deduce the instantaneous rate of change. So now let's start by quoting down the formula, right? So now we know that the average rate of change is equal to f of t2 minus f of t1 divided by t2 minus t1, right? And t2 is 1 plus h and t1 is 1. So let's plug them in. We are going to have f of 1 plus h minus f of 1 divided by 1 plus h minus 1. Let's simplify. We are going to have f of 1 plus h minus f of 1 all divided by, now 1 minus 1 is 0, so we are going to have h. Now we need f of 1 plus h and f of 1. So the trick, let's write down the function. F of t is equal to 1 minus 2 t squared. Now the trick is make sure all the t's are in what? Parentheses. So we are going to have f of t to be equal to 1 minus 2, and I put my t in parentheses. Very nice. Which will help me to now look for f of 1 plus h. So what is f of 1 plus h? So we are going to write everything here. We just change the one in the parentheses to 1 plus h. So you see the trick. So this minus 1 minus 2, 1 plus h squared, right? So now we can see that the one in the parentheses here is the same thing here. The one in the parentheses here is the same thing here. Good. So now let us expand. Minus 2. Now 1 plus h squared can be written as 1 plus h, 1 plus h, right? So this is going to give us 1 minus 2. Now we are going to multiply the 1 by the 1 here, 1 by h here. Then we pick 8 to multiply the 1, and we pick the 8 to multiply this one too as well. So we are going to have 1 times 1 is 1, 1 times h is h, h times 1 is 1, and then 8 times h is h squared. So when we simplify, we have 1 plus 2h plus h squared. Then we will multiply through by negative 2. So we are going to have 1 minus, so negative 2 times 1 is 2, negative 2 times 2h will be negative 4h. The negative 2 times h squared is going to be negative 2h squared. When we simplify, 1 minus 2 is negative 1 minus 4h minus 2h squared. So now this is f of 1 plus h. Now let's look for f of 1. Then we just go and plug it in. So f of 1, we are using the same function here. So the 1 in the parentheses now change to 1. So we are going to have 1 minus 2, then 1 squared. Right, we are going to have 1 minus 2, 1 squared is 1, 1 minus 2 times 1 is 2, and this is going to give us negative 1. So another trick that we can do is, instead of putting this up here minus this, what I'm going to do is I'm going to solve for this, the final answer, then I'll come and place it here. So now let's look for f of 1 plus h minus f of 1. So we look for f of 1 plus h minus this, right? Now what do we get for f of 1 plus h? F of 1 plus h was this, right? And then f of 1 was this. So let's combine them together. We have minus 1 minus 4h minus h squared. And remember the trick, right? Minus, you put it in parentheses, right? Let me shift this one small. minus, then f of 1 is minus 1. So let's try and simplify. This one will be minus 1 minus 4h minus 2h squared, minus will be plus 1. Now we can see that plus 1 and minus 1 will go away. So we are going to have negative 4h minus 2h squared. So the one up here is here, which is equal to this, right? So let's come and put it there. We are going to have negative 4h minus 2h squared divided by h. Now we can see that we have h here, we have h here, so we can factor one of the h out. So h out. Now with this one, when I factor h out, it will be left with negative 4. So this one will be left with negative 4. With this one, when I factor h out, it will be left with negative 2h divided by h. Oh, that is nice. So now this will cancel this, and we are going to have negative 4 minus 2h. So now this is the average velocity, right? Or the average rate of change. Now the next question is, what is the instantaneous rate of change of f of s at t is equal to 1? So we can see that here the only change, if we are looking at the graph, if we are drawing a graph, let's assume that we are drawing a graph like this. Let me just draw a graph, nice graph. So let's assume that we are drawing a graph like this. Now we have t is equal to 1 and t is equal to 1 plus h. So we are looking at this, and here is t is equal to 1, and here is t is equal to 1 plus h. Now since the question is asking us to find the instantaneous rate of change at t is equal to 1, then it means that the tangent line should pass through the point when t is equal to what? 1. So what is happening there? What is happening here is the tangent line does not pass through the one with h. So it means that that place is when h is equal to what? 0. So now the instantaneous rate of change is equal to limit as h is approaching what? 0. So now we are looking at limit when this h is getting close to 0. So when we are moving, when we are coming close to this one, we come to when h is equal to what? 0. So now the idea is that since the average velocity depends on h, we need to use the final answer that we had, minus 4 minus 2 h. Then this one should be equal to, so we are going to plug in the value. So this one is negative 4 minus 2h, negative 4, and this one will be 0, and this one is going to give us negative 4. So you see, this is so nice. You need to get the average velocity. It means that when you get the average velocity wrong, actually the instantaneous velocity too is going to be what? Wrong. So now let's look at the summary. We said we want to find the average rate of change of f of t from t is equal to 1 to t is equal to 1 plus h. So the first thing that we need to do is we need to write down the formula for calculating average rate of change. Then if I'm using b here, a here, I need to go and look for my a and b. Here we are using t2 and t1. So I need to look for t2 and t1, which t2 is this one and t1 is this one. So the first value here should be the one that will be the last value here, right? This from here to here, and the first one will be the one here. Good. And then we just did substitution, we simplified, and we got to this stage. So when we got to this stage, then we need f of 1 plus h, we need f of 1. So we need to go and take our function, which is given here, and we said the strategy is, as soon as you write the function down, make sure, since this t is in parentheses, make sure the t in this function too is also in what? Parentheses, which we did here. Then we need to look for f of 1 plus h, which is right here, right? So now what is in the bracket here is the same thing, so we are just changing the one in the bracket. or the parenthesis. So this one is the one here. The same function, we have the 1, we have the 1, we have the -2, we have the -2. The only thing that is changing is the 1 in the parenthesis. So that is the idea. We expanded and then we had this. Then we look for f of 1, 2, the same process. We had this. And then we said, instead of coming here to write equal to this minus this, let's rather solve the one up here, which is here. Let's simplify it first. So we simplified and we got this, and then from there we place this one here, right? So we brought this one here divided by the h, and we factored h out, h cancelled out, and we had this. And we said the instantaneous rate of change is the slope of the tangent line, which does not depend on h, right? So it means that h should get to 0, because this is when we are getting close to when t is equal to 1. And we plug in 0 and then we get -4. So in the next video we are going to look at another example.